monazite and titanite uranium lead analysis of the Grampian Shear Zone, Badenoch Group, and the Grampian Group. So this was undertaken for my master's MSc by research at the University of Hull under Anna Bird and Eddie Dempsey. So regional geology we'll have to cover briefly here, is we'll be talking about the Central Highlands here and the Northern Highlands here. So the Northern Highlands that we're interested in contain the Moyne, so that's a metasedimentary stack of Neoproterozoic and Caledonian deformed metasediments. And then in the Central Highlands, we're talking about the Badenoch Group and the overlying sediments. So that's just about here. The Badenoch Group itself is split into two subgroups. That's the Dava and the Glenbanker subgroup. So the lower of the two is the Dava, and this group is migmatic, whereas the Glenbanker above is just a series of metasedimentary Semitic gneisses, sorry. And structurally high up within the Glenbanker group, there is a shear zone that is host to a series of mainlandized pegmatites. Previous geochronological studies of the Badenoch group dated migmatization within the Dava group at 840 MA and dated monazites within the shear zone at 806 MA, and these were interpreted to represent or reflect initial shearing within the shear zone and the genesis or generation of these pegmatites. So because we're talking about Neoproterozoic deformation within Scotland, it's useful to talk about the Valhalla Origin. So this is a accretionary origin along the margin of Rodinia, and within Scotland, we can split this into two phases: the Rhenlandian, which is an earlier phase, and the Neudartian, which is a younger phase. So the Neudartian itself can be split into two distinct episodes: an older age episode related to sedimentary deposition and orogenesis from 840 to 780 MA, and then a younger episode from 740 to 725 related to pegmatite genesis and shearing. And because we're looking at primarily at the Central Highlands, it's definitely useful to talk about the Caledonian origin. So the Caledonian origin is a multi-phase origin, and within Scotland, this is split into three main phases: the Grampian, a Grampian 2, and the Scandian, with the Grampian being related to ophiolite abduction and related magmatism, metamorphism. Grampian 2 being somewhat elusive and primarily found within the Moyne and within Shetland, and the Scandian reflecting the Moyne thrust stacking, and that is mostly found in the Moyne as well. So the aims of this project are to directly compare geochronological and structural analysis within in situ samples, so in situ LA-ICP-MS analysis of the samples, and then a direct comparison of the Badenoch Group, the Grampian Shear Zone, and the overlying Dalradian metasediments. And particularly for monazite, we mapped monazites to look at yttrium, rare earth, and major domains, particularly uranium and lead. And the samples are taken from the Central Highlands, so around the Badenoch Group here, and then there are some within the shear zone, which is sort of on the edge of the Badenoch Group, and then within the overlying Grampian group of the Dalradian Supergroup. And the first sample I'll discuss is the sample RG1710, the Findhorn metasediment. This is assigned to the Badenoch Group. It outcrops on the River Findhorn, and we've dated titanites within this sample using uranium lead LA-ICP-MS analysis. Interestingly, some of these titanites contain rutile inclusions, which have a pre-existing higher grade mineralogy for this sample. This sample was dated using a Discordia analysis at 469 MA. The Lochindaub garnet amphibolite, which is hosted within the Grampian Shear Zone, we dated titanites within this sample. These titanites were hosted within garnet cores, and garnet cores were identified by inclusions of titanite, ilmenite, and quartz. And these titanites were dated to 467 MA. And the garnet cores therefore must either predate, titanite, sorry, must predate or date the growth of these garnet cores. For monazite, as I said previously, we mapped them, and after mapping, we've dated them using uranium-lead spot analysis. So the monazite we've mapped and dated from the shear zone is from the Corie pegmatite. This is a pegmatite that is deformed on the sort of hand specimen and outcrop scale. And the monazite we've mapped and dated within shows low bait uranium and lead domains, and shows evidence of fluid grain interactions, particularly because near the grain, there are smaller grains of associated fluorite and xenotime. So fluorite is a very strong indicator of fluid interactions of monazite. And interesting to note is that the monazite uranium lead domains don't quite overlap. So if I highlight on the lead map, this region and this region, you see that while uranium here is rather low, the lead remains quite high. So this suggests that uranium has been preferentially moved to the lead domains. Oh, apologies for that. And this monazite was dated using uranium lead in situ analysis. The oldest cluster within the Neudatian produced a cluster around 825 MA, with the youngest Neudatian spot at 712 MA. The Grampian overprint within this sample was at 485 MA. This is quite early on for the Grampian. The other monazite we dated was from the Ruthven Semipelite. This is a semipelite within the Corie subgroup, the Grampian group. So this is a Dalradian metasediment. This produced a Grampian age cluster at 476 MA. And many of the spots within this particular mapped and dated monazite are plotted to the right of the Concordia with elevated sort of inherited levels of lead. And this is also associated with a region of higher yttrium and heavy rare earth elements. Also within this monazite, 4 spots plotted on the Concordia that were older than the Grampian age spots, and these range from 489 MA to 516 MA. The upper intercept for the perhaps inherited region of the monazite produces an upper intercept of 2.3 gigaages. So yeah, may represent a inherited Paleoproterozoic monazite grain. Interpreting the monazite uranium lead ages from the sheared pegmatite of the Grampian Shear Zone. So the oldest Neoproterozoic age produced within this monazite was 825 MA, and this is interpreted to date the initial monazite growth within the pegmatite, perhaps even the growth of the pegmatite itself, and date shearing along the Grampian Shear Zone. This is older than the previous study that looked into these pegmatites and that gave ages of 804, 806, and 808 MA. With the Neudatian overprint we've seen, this produces at least a cluster around 748 MA, but you could arguably split this up into 2 separate clusters around 767 and 794, with an early Grampian overprint for this monazite at 485 MA. The uranium lead ages from the Ruthven Semipelite shows metamorphism within the Dalradian Supergroup producing monazite at 476 MA, and this particular grain may reflect an inherited Paleoproterozoic monazite within the sample. And this region's related to higher yttrium, dysprosium, cadmium, lutetium, terbium, lower thorium, uranium, and lead within the produced monazite maps. For the titanite uranium lead analysis, the Findhorn formation from within the Badenoch Group, so that's the basement group to the Dalradian Supergroup, produced titanite growth at 469 million years ago, indicating metamorphism of fluid flow during the Grampian orogeny, and the rutile inclusions present within some of these titanites indicates a pre-existing higher grade mineralogy. The titanite uranium lead geochronology from the Lochindaub garnet amphibolite from within the Grampian Shear Zone. This provides a maximum age of the garnet cores of 467. These garnets have well-developed shear zones, and the lithology itself is sheared. And so this suggests shearing after the growth of these titanites, and therefore after the growth of these garnets. So the monazite uranium-lead analysis shows pulsed Neodartian ages within the Badenoch Group, and these pulses fall within both Neodartian groups. So that's the older Neodartian and the younger Neodartian. The Grampian metasediments only show metamorphism from the tectonic activity related to the Grampian orogeny of the Caledonian orogeny. And because the RG1716 monazite, that's the Grampian Shear Zone Pegmatite monazite, shows both pulses of Neodartian, that suggests a strong link between the Badenoch Group and the Moyne north of the Great Glen Fault. So it points to a strong affinity, as I said. And from all of this data, we can interpret that the Grampian Shear Zone was initiated during the Neodartian, and we can argue that it was initiated during the initial Neodartian phase of sedimentation and orogenesis. It was active during the opening of the Iapetus Ocean and the subsequent deposition of Dalradian sediments, and was reactivated during the Caledonian orogeny. Thank you.
Thank you very much. That was a great talk and really interesting results. And are there any questions for Lewis? Yeah, there's some questions, lots of questions, but also everyone says very nice talk, which these was. Catherine was asking, can you use the trace element maps to help you interpret whether dissolution reprecipitation has occurred in your grains? Dissolution reprecipitation processes are typically more important than diffusion process in monazite.
I believe so. So, yeah. So, because the uranium domains themselves are quite low bait, that sort of does lend itself to dissolution and reprecipitation within the grain. I believe I read a study that showed uranium would then deposit out of the monazite as hotspots as uranite, and there is within this monazite, the shear zone monazite, there is a hotspot of uranium. So perhaps that's reflecting a uranite coming out of the monazite crystal.
Yeah, seems like good evidence for it. Another question from Hugo, who's asking, have the discordant monazites that project an upper intercept age of 2.3 giga-years been corrected for common lead?
No, no, because it's a monazite grain. So my understanding is that monazite doesn't often contain common lead.
I guess it depends on the monazite.
Yeah.
But so you haven't
No.
corrected them. Okay. There's another question from Sebastian. He's also congratulations for the nice talk. Is there any microstructural evidence to link monazite ages with specific recrystallization mechanisms?
I'm not actually too sure on that. So
that's okay.
Apologies.
And I think one last question. Just to point out that the amphibolite in the data and Denenbacher have eclodite relics, so the older shear zones ages give.
Yeah, so I don't believe that this particular garnet amphibolite is related to these eclogites. So it's hosted within the shear zone, and the titanites that rim ilmenite, they don't seem to have any particular fabric, and they do provide a sort of older age limit for these garnets. But yeah, those eclogites certainly do need looking into.
Sounds good. Even more future research.
Yeah.
Great. Thank you very much. It was a great presentation. And for time reasons, we move on now. But you can maybe have a look, and there are some further comments in the chat.